Hello everyone and welcome to episode 5 of Fusion 360's Tech Thursday. Today's session is about assemblies and joints. I get asked this question quite often, what's the best way to assemble components together inside of Fusion 360? So I'm going to show you some of the basics, and then I'm going to show you some tips that I've learned using the assemblies, making things a little bit easier to work in complex assembly. So let's dive right in. Okay, so what we're going to talk about today is this assemble menu. Now, I have been asked in some of the chat that my menu looks a little bit different than what you're used to. Typically, you would come over here and go to assemble or whatever. That was the previous version. What I did is under preferences, preview, we have this UI preview, and I highly recommend taking a look at it because we've spent some time making the menus a little bit easier to use, a little bit more manageable. All the commands are kind of right here across the top, such as your solid modeling, your surfacing, your sheet metal, and then the assemble menu, and this is where we're going to kind of focus today. I'll also share the files that you see. That way you can play around with these. So I'll put those in the description a little bit later. Okay, so you can see on the screen I have a bunch of different components, and I can tell that they're components because of the little cube icon. If they were bodies, they would have a little cylinder icon. Now you have to have components to assemble things, okay? And again, I've talked in a previous live stream the difference between bodies and components. So if you haven't seen that particular session, I'll also link to it in the description. Highly recommend watching that one. I talk about the difference between a regular body and a component. And we also talk about how if you want to assemble anything, if you want things to interact with each other, they have to be components. Okay, so under the assemble menu, in fact, you'll see the very first command is new component, but then there's the joint command, okay? And there's two different kinds. You'll see the joint command and then as-built joints. And I love as-built joints. In fact, you'll see me, I'm gonna show how powerful these are here in a moment. But we're gonna start with the joint command, okay? And what this does is it brings up the joint menu, and sure enough, you can see that it says component 1 and component 2. So it basically tells you, hey, these have to be components to be able to position them. One of the other questions I get asked a lot is, well, how do you know which one to move? Like, how do you know where it's going to go? And so a little trick that I've come up with is using these little numbers right here. Which one do you want to move? And where do you want to move it to? So that's kind of how I remember how this thing's going to work. So for example, if I wanted to move this, cube shape right here, this would be my component 1. This is the one I want to move. And where do I want to move it to? I want to move it to this other gear housing down here. So hopefully that's a little trick that you'll remember that I use. That helps me remember. So I'm going to say component 1 is going to be this guy, okay? Now, just looking through this menu really quick, the other important thing is this motion type. And you'll notice it remembers the last motion type that we've used. And in this case, I had done a pin slot example. But you can see we have rigid, revolute, slider, cylindrical, pin slot, planar, and ball. And so I'm going to talk about these. So rigid basically ties down all degrees of freedom. Okay? Let me show you what I mean by that. So I'll use this cube as an example here. So typically especially in other CAD systems back in the day, when you wanted to move something, you would basically say, for example, mate that face with this face over here. and it would basically slide, and I'm just kind of freestyling here, it would slide that over until those faces were in line with each other. Then you might say mate that face with this face down here, and it would slide the part down until it was touching, and again I'm just kind of freehanding it here, but now you can see how it's touching that face down there. And then finally you might say something like mate that face with this little tiny face right here, and it would slide this forward, etc. But you can see it's basically tying down those degrees of freedom. So it was basically saying this wall over here has to touch this wall over here. The bottom of the block has to touch the bottom of the part, and the front of the block has to touch that other face. And so you're tying down those degrees of freedom. It could also rotate around, for example, this axis, or this axis, or this axis. And so that's your 6 degrees of freedom. It can move left or right, up or down, forward or back. It could rotate around any of these other axes. Okay, so when we were designing Fusion, we said there's got to be an easier way. And so what we do is we actually tie down all degrees of freedom and then open up the ones that make sense. So for example, if I wanted this rod to slide through this block, I don't want it to move up and down. I don't want it to move left or right. I don't want it to rotate around any edges or anything like that. The only thing I want it to do is to be able to slide forward and back through that block. And so we would tie down all those degrees of freedom and open up that 1 degree of freedom to allow it to slide forward and back through the block. And you'll see this as we start to go through. Okay, so let's go ahead and do a joint command. So I'm going to say joint. What's the one that I want to move? Well, it's this guy. And where do I want to move it to? I want to move it to this kind of shaded block right now. And I'll explain that in just a moment. I'm going to zoom up on this, and you'll notice as I move around, I get a lot of little icons that appear. And they appear on a bunch of different faces. And again, depending on what you hover over, you're going to get different results. Okay? So what these little tick marks are is it kind of helps guide you. So it's kind of hard to see, but there's little round ones in the corner. Those are endpoints. There's little triangles in the middle. Those are, I can't really point to them, those are midpoints. So I could catch to the middle of this edge, for example. So circles are endpoints, triangles are midpoints. Then you'll see a square right in the middle, and that's basically the centroid of that face. You'll notice if I come over here, we can see the square right here in the middle. Let me kind of move out of the way. You can see the circles and the triangles. Let me go to something that has some other geometry on it, like this. Notice in the circle there's a little plus symbol. I'm kind of hovering over it right now. I'll move away just a little bit. That's the center of a cylinder or a circle, so it's like an axis. Okay? So what this allows us to do is we can pick very specific points. So in this case, for example, maybe I want to grab this upper right corner. So I'm just going to go ahead and click on that upper right corner. And you can see component 1 has now been selected. Where do I want to make it go to? I want it to go to this green part, but I want it to go to a very specific location. I want it to go right there. So I'm basically telling it, line up those 2 corners. So watch what happens when I go ahead and click on, let me change this guy to rigid. I'll click on this point, and you'll see that that gray block is going to move into place. Let me go ahead and animate that. And you see it kind of shake. So The shaking, you'll see on all of our motion types, we have an animation that kind of shows, is it going to slide? Is it rigid? So it's kind of shaking, showing that it's rigid. Is it revolute? So you'll see all of these as we go through. So the shaking is kind of showing that, hey, these are rigid with each other. We've basically glued them, welded them, press fit them, whatever term you want to use. They are rigid with each other. Okay? So I'll go ahead and say okay, and we can see that sure enough, it moved that gray block from up here down to here. And if I try and grab this gray block and click and drag it, like for example, I can drag all of these other parts no problem, but I can't grab this gray part anymore because it is rigid with this green part. Okay. Now, with that said, there's a tip here that I get asked a lot also, is how come you can move these other parts but not these? You'll notice on the gear housing icon, there's a really small little thumbtack icon. And you don't see that on any of the other ones. And that's because I've grounded this part. Okay? You basically have to tell Fusion which part is stationary, which part are you holding on to, which part is bolted to the table or whatever, and you would pick that and ground it. So you can see right here that the gear housing is grounded. So I'm going to actually unground it, and you'll notice that the pin goes away. Now watch what happens when I grab that gray block. It moves with the green gear housing. Okay, that's because Fusion doesn't know which part is supposed to stay stationary. All it knows is that they're rigid with each other, so if one moves, both of them has to move. Okay, so we need to tell Fusion which part is stationary. So here's another trick. If you click on a part, it actually highlights it in the browser. You can kind of see that line right there. So for example, if I click on this one here, you'll see that's the connector rod. If I click on this guy here, that's the crank arm. So instead of trying to remember what did I call that part, you can just click on the part and it highlights it in your browser. So I'm going to right mouse click on it, and up near the top is the command called ground. So I'm going to go ahead and hit ground. We can see that that little pin icon shows up. And now if I try and click and drag that green part, you'll notice that I can't. It's being held in place. Okay, let's continue on. Again, I'm going to use the joint command, or the J key is the shortcut. So I'll say joint. Which part do I want to move? Which one do I want to move? Well, I want to move this gray part. Where do I want to move it to? I want to move it to this block down here. Okay, so again, I can kind of like hover over certain things or whatever, but what I'm going to do here is basically say I want this edge to line up with this edge in here. Okay, so I'm going to hover over this edge, and you see that little round icon appear. This is what we call our joint origin. And you'll notice as I get near the middle, it kind of snaps toward the middle. If I get near the end, it's going to snap toward the end. So every edge has a start point, a midpoint, and an endpoint. Doesn't matter which edge it is. Okay? Each edge has a start, a middle, and an end. So what I'm going to do here is basically say, you know what? I want the middle of this rod lined up with the middle of that block. So I'm just going to get kind of near that middle mark right there and click. Where do I want it to go to? I want it to go to this other part. I'm going to zoom up a little bit so you can kind of see what's going on here. And again, you can see this edge has a start, a middle, and an end. So I'm going to go ahead and grab the middle there and watch what happens to my rod right there. It moves into place, and you saw the animation of it being rigid. Okay, it's tied down all degrees of freedom. Well, obviously in this case we don't want to tie down all degrees of freedom. I want it to be able to slide. So I'm going to change my motion type from rigid to slider. And instantly it opens up that 1 degree of freedom. In fact, I'll hit animate so you can kind of see what that looks like. So it opened up that 1 degree of freedom, so it can slide forward and back, but it can't rotate, it can't move up and down, left or right, etc. I'll go ahead and say OK, and now that part is in place. And if I try and drag on it, notice the result that I get. It actually allows me to slide back and forth. Doesn't matter if I move my mouse up or down, left or right, or in circles or whatever, it's only going to slide in that one direction. Okay? Now, I have not set any limits or anything like that, so you can see we can actually like clash with that other part, which in reality you wouldn't be able to do, but we're going to learn about limits here in just a moment. So hopefully this is making sense. Now, honestly, coming from other CAD systems, I actually find the joints command in Fusion to be one of the easiest ones to understand. You basically say, I want to go from here to here, and I want it to do a certain kind of motion, whether it's a revolute, whether it's a slider, whether it's a rigid, etc. So if you're coming from other CAD systems, this could be a little bit different than what you're used to. But play around with it and you'll see, hopefully like I did, that it's actually pretty easy to use. Okay, so let's continue on here. We have this gear floating up in space. So I'm going to go ahead and again do the joint command. And let's zoom up on this guy. Now remember I showed you like when you hover over faces, you get these different tick marks. Watch what happens when I hover over this guy. You can see it actually gives me tick marks for all the gear teeth, etc. But the one I'm most concerned about is this edge right here. And notice what it's doing. It's actually snapping to the center of this circle. So this is actually doing almost like 2 things in one. It's finding the center axis of that edge, and it's finding the plane that that edge is on. Okay? So I'm going to go ahead and just hover over like a circular edge and click. So that's the component 1 that I want to move. Where do I want to move it to? I want to move it to this edge down here. Okay? So I'm going to go ahead and click, and you'll see it move it into place, but then we see kind of a weird result. Okay? Now why is it going up and down through the part? Well, Fusion remembers the last motion type that you've used. And the last one that I did was the slider. So it basically said, okay, you're probably still wanting to do a slider. Well, obviously, no, we don't. So I'm going to come in here and say, instead, I want it to revolve. As soon as I hit Revolute, you'll notice that it ties down all degrees of freedom, translational freedom, and it opens up that 1 degree of rotational freedom. And it's pretty cool. I would say like 99.5% of the time it figures out the correct direction to turn, but you can see you actually do have control over here. For example, it's rotating around the z-axis. I could say rotate around the x-axis. Now that doesn't make sense in this case, but you can see that sure enough it's revolving around the x-axis or the y-axis. But we obviously want the z-axis. Okay? I'll go ahead and stop the animation. Now, what happened here? Well, I told it to line up the bottom of the gear with the top of the hole that goes through the green part. So if we were to section through right now, this gear is basically sitting on the floor of this green part. Well, you'll notice that we have some alignment options here. And we also have these arrows over here. Let me just start with the arrows. I could just grab this gear and drag it up. And you can see, sure enough, we're offsetting it 44 millimeters in the Z direction. So even though I told it to line up this bottom edge with this inside edge, it's kind of hard to highlight, we're telling it offset a certain distance from that. So if I wanted a little bit of clearance, I could say offset it 1 millimeter or whatever, and it's going to do that. I can also specify which angle I want this to be. So let's say I want that to be at 45 degrees. I can do that also. Okay. I'll hit OK. And now it's at 45 degrees, but I can come in here and drag on this guy, and you can see how we can rotate that around. Okay. Okay, let's move on here. Let's continue with these little bushings that we see kind of floating out here. I'm going to assemble these bushings into this blue part kind of out here in space, and then we'll move the whole blue part subassembly into location. So let's go ahead and do a joint command. And I'm going to just get near this top edge right here. And I'll go ahead and click. This is the one I want to move. And where do I want to move it to? I want to move it to this blue part. Now here's the catch. I'm going to zoom up a little bit here. And if I get really close, you can actually see that there is a very small fillet on this blue part. So that actually gives me two edges that I could catch to. And one of them is lower than the other because it's a fillet. So we want to be pretty careful which edge we're going to catch to. Okay, so I'm going to kind of go like this. You can kind of see as I move around, the circle get a little bit smaller, a little bit bigger, that kind of a thing. So I'm going to make sure I'm clicking on that outside edge. And you'll see that that bushing moves into place, but we can also see that it was revolving around. Again, Fusion remembers the last motion type, which was a Revolute. In this case, we're going to say it's like a press fit bushing. So I'm going to come in here and just say rigid. And I'll say OK. So if I grab my blue part and move it around now, we can see that that bushing moves with it. Okay. I see in the chat window somebody asked, where can we get this example file? I will post it out into the description once the video is posted out onto YouTube. It's not out there right now, but come back in a little while and I'll have that in the description. So thanks for asking about that. Okay, so let's do this other bushing. I'm going to go ahead and say joint, grab the bottom edge, but this time I'm going to purposely make a mistake. And let's pretend you didn't see me make this mistake, but I'm going to go ahead and put it on that wrong edge, on that inside edge. So I'm going to go ahead and click there. It moves it into place. It remembers my last motion type was rigid, so this one's rigid. I'll say OK. And let's say I've done a bunch of other stuff, so I can't really use the undo command very easily. But as I'm looking at this, I can see, oh my gosh, there's a little bit of a standoff right there, where the other one there isn't. And so if we look at the bottom, sure enough, we can kind of see it's positioned incorrectly. So what do we do about this? Well, all I have to do is go into my joints folder right here, and here it's displaying all of the different kinds of joints that we've created. In fact, let me zoom out so you can kind of see. There's our first rigid joint that we did, and you can see it highlights it in my timeline. There's the slider joint right there. And it's a little hard to see, but you can see that each joint type has a different icon. So this one's showing it's going to slide in that direction. The little Lego bricks locked together kind of show that they're rigid with each other. If I click on a Revolute, you can see it has like a little flag. In fact, when I rotate this, you'll see that that flag actually updates with the, it's hard to see, the angle in there. It says 65 degrees. Okay. But all I have to do is click on this last one, and I can see that sure enough it highlights that particular joint and say edit joint. And it brings up my joint command. Now, I can make the assumption that the component 1 that I clicked on was correct, but where I put it to was incorrect. So I'm going to hit the little X next to component 2, and you'll see that the part kind of goes away. But it's now allowing me to select component 2 again. So I'm going to be more careful this time. I'm going to grab this outside edge. And you'll see that it brings it in place, but it's upside down. Well, that's where this flip icon comes into play. If I just click flip, you can see that we can flip the orientation if we need to. But sure enough, it looks more flush. That one there looks flush. It's looking good. I'll go ahead and say OK. So you can always edit existing joints. In fact, we could come in here and say, you know what? Instead of a rigid press fit joint, I want it to be a revolving joint. And you can see it's animating that thing is revolving around. Okay? So you can always come back and edit your joints if you need to. Okay. Let's go on to this red part here. So again, I can click on the joint command, or I can just be out here and hit the J key on my keyboard, J for joint, and you'll see that it brings up the joint command. Again, I'm going to make a mistake. I'll go ahead and click on this top edge. I'll click on this top edge, which should be correct. It puts it into place. It's a rigid. It looks good. But when I look at it from the side, we can see that the red bushing is sticking out through the bottom. Well, why is that? Well, it's actually because the red bushing is taller or thicker than the blue part. And I told it to line up the top edge with the top edge. Well, I obviously want it to be equally spaced, okay? So I'm going to undo, in this example, I'll just say undo. And here is one of the tips that I want to share with you. I'll say joint, and instead of picking on an edge, I'm going to hover over like a cylindrical face. And you'll notice that a cylinder has a top, a midpoint, and a bottom point. Same thing over here. This cylinder has a top, a middle, and a bottom point. So I should be able to line up the middle of this cylinder with the middle of this cylinder. So that's what we're going to do. I'm going to hover over this face right here. And I'm going to grab this middle point. Okay. Then I'm going to come over here and do the exact same thing. I'm going to hover over and I'm going to grab the middle point. You'll see that it slides over. And if we look at it from the side, we now have some equal spacing because it basically lined up the midpoints of those cylinders. Okay. I'm going to cancel out of that. And I'm actually going to show you another little tip that I find very, very useful that not a lot of people know about. So when I positioned this red cylinder over here, you'll notice when I do the joint command, I get a lot of flashing. So it's trying to catch to edges, to faces, to edges, to cylinders, inside cylinders, outside cylinders. It can get pretty confusing trying to catch that middle point right there, okay? What I want to be able to do is to control my selection. And that's the exact key you want to hold down. So notice as I'm moving around, it's catching to all of these edges and faces and stuff like that. But when I hover over this cylinder, I can kind of see what I want. So I'm going to hold down my control key and now notice that it is not snapping or selecting or highlighting those other edges. I've controlled my selection to just be this outside cylinder. As soon as I let go of my control key, I'm back to catching edges and faces, etc. But if I hover over this guy, hold down my control key, now you'll notice I'm controlling my selection to that inside cylinder. So again, I'm using a little saying. I want to control my selection, and that helps me remember to use the control key. Same thing over here. As I'm moving around, it's trying to catch to faces and edges, etc. It can get pretty confusing. I just hover over, I hold down my control key, and you'll notice now, even though I'm moving over on these other faces, it's not highlighting or snapping to those. Okay, so I'm going to go ahead and control my selection to that middle point and say OK. So you hear me say a lot of times, I come up with these little sayings, like which one do you want to move, where do you want to move it to, use your control key. Again, I'm hoping these are helping you. They help me. Trying to remember which order do I do things and how do I get that selection to happen. So let me know if this is helpful. If you didn't know about this or whatever, throw it in the comments. I like to learn that you guys are learning from these web sessions. So let me know. Okay. Now I have this blue part fully assembled. In fact, if I move my blue part, we can see that everything moves with it. Okay. So now all I have left to do is to put it into place. And I'll use the joint command one more time. What's the one that I want to move? I want to move this blue part. So I'm actually going to go underneath this blue part a little bit and grab maybe this circular edge right here. Okay. Which component do I want to move it to? Well, I want to move it to this connector rod here. And again, I have to be a little bit careful because there's a chamfer here with an outside and an inside edge. So I want to make sure I grab this outside edge. I'm going to go ahead and click. And we're going to see a couple issues. Okay. First thing is we see our bushings that we just assembled floating out here in space. And this freaks a lot of people out. They're like, hey, I just assembled those. Why didn't they move? And the answer is actually right here. We're only dealing with two components at a time. The one that we want to move and the one that we want to move it to. Okay, so we're dealing with the blue part and the gray part. As soon as I say OK, Fusion says, hey, those bushings are supposed to be in the middle of the blue part, et cetera, et cetera. And so it updates it as soon as I say OK. However, here is the issue that we're going to see. If I look at this from the side, we can see that it did exactly what I told it to. It lined it up exactly on top of that gray part, but we can see that there's a gap here. And again, this is because the gray part is thinner than the blue part. Okay, so let's go ahead and fix that. You might be saying, well, all you need to do is do the cylinder thing like we did with the red part. However, there's no cylinder in here. There's no midpoint to catch. So here is one of the other tips that I'm going to show you, and that is a command called between two faces. Again, not a lot of people know about this, and I'm going to show a couple examples of this. We'll do this blue part, and then I'm actually going to go to another part just to kind of show you how useful it is. So I'm going to say joint, then I'm going to right mouse click, and you'll see there's an option here that says between two faces. Now we have to remember that it's in the right mouse click menu. So I'm going to say between two faces. I'll grab maybe this face here. I don't even have to rotate. It actually knows, hey, you're going to select a planar face. So we're going to grab this face right here. And then, let me kind of move up here. I'll hover over this circular edge. And I'm going to pause here for a moment so you can kind of see what's happening on the screen. It's hard to see, but there's that little tan or orange, whatever color you want to call it, plane between those two faces. It's almost like a mid-plane between those two faces. Then we can also see the joint origin is on that plane, in the center of that axis. So we're basically saying, let me click a point out here in space that's on the axis of this circle. So I'm going to go ahead and click that guy there. In fact, if I hover around, you can see how that's kind of just in the middle of space right there. But it's perfectly lined up in the center of the circles. Then I'll come over here, control my selection to the midpoint here, because we caught basically the middle over here. We're going to catch to the middle over here. We'll see it slide into place. Let's kind of look at it from the side. And sure enough, we can visually see that we have equal spacing now. And hopefully this made sense. We basically said, find the center of the circle here in space between those two faces. Okay. Let me zoom back out. The last thing is, you'll notice that it thinks it's a rigid joint because that's the last one that we did. Well, I want this to be a Revolute joint, so I'm going to turn it to Revolute. We can see that sure enough, that's revolving around that axis. I'll say OK. And there we go. All of my other bushings move into place. And if I grab this blue part, we can see that it revolves, but it's also kind of forcing the slider to only be able to slide. So it's kind of limiting my motion a little bit, but we can kind of see how this is going to work. Okay. So the very last thing we need to do is to connect our blue part with the gear, but you'll notice we're actually missing a component. We don't have a pin that goes through these parts. Well, you don't actually have to have a solid model to create a joint. So I'm going to come over here and say joint. Again, I'm going to make a mistake here to show you the power of Fusion. So I'm going to say, let's line up the top of this red part with the top of this gear. And you'll see it's going to move it down and it kind of simulates it, but you'll notice I get a warning that says the selected joint type would result in a conflict. Well, what does that mean? Well, it's trying to put this red part way down here, but Fusion knows, hey, I'm supposed to be up here, so I physically can't do that. Okay? And physically you couldn't do it anyways because they would intersect each other. So I want it to be able to revolve, but I also need to be able to have it move up or down so it can be in the correct location on this part up here. So we're actually going to open up 2 degrees of freedom. And we're going to use a cylindrical joint. And what this does, it actually opens up a rotational and a slider joint. And it's kind of hard to see in the animation, but you'll see it moving up and down, but it's also rotating around. Okay? So when I say OK, it actually updates this. So you can kind of see as I rotate around, we're now lined up with that gear and the red part moved into the correct location. Okay. And if I rotate this gear around, we can actually simulate how this is going to work. Now, you'll notice it gave me some red arrow or red exclamation points saying, hey, this can't work. But as soon as I hover over those, it basically updates them. And obviously this does work. So I'm going to go ahead and rotate this around and we can simulate that this is actually an assembly from like a Sawzall machine where a motor turns the gear and a blade is connected to this particular rod right here and moves forward and back. So that is the basics of using the joint command inside of Fusion 360. I'm going to show a couple of the other joint types, and then I'm going to show you the as-built joints, which I think are awesome. So here's a cool example. I'm going to go ahead and say joint again. So we've talked about rigid, we talked about revolutes, we talked about slider, and we've talked about cylindrical. Then we have pin slot. So pin slot is basically exactly what it sounds like. If you had a pin that needs to move forward and back through a slot, and rotate, for example, it opens up those degrees of freedom. Planar is like a hockey puck on an ice rink. You want it to be able to move like in the X and Y direction, in any direction in the X and Y, but you don't want it to move up and down, for example. And then ball joint ties down all translational degrees of freedom, but opens up rotational degrees of freedom. In fact, let me show you that one. This is actually kind of cool. Let's just insert a Mcmaster-Carr component. So I'm gonna go out to Mcmaster-Carr, and let's just do a search. Let's just do a search for a ball joint. I'm gonna say ball joint. Actually, you know what? Let's do a U-joint. This is pretty cool. Let's do a U-joint. And I'm just going to grab this guy here. And in Mcmaster-Carr, if you see this little CAD symbol, it means that there's a three-dimensional representation that you can download. You can see there's a drawing of it. And I have it set to step, so I'm going to just say save. And in less than a second, it brought this in. Okay. Now, if I open this guy up, we can see that there's some bodies here. And if I try and drag this, you can see it moves everything around. So I want these to be components. So I'm going to say create components from bodies. So now I can actually separate these and move them around individually. So that's proof to me that they're components. I'm going to go ahead and click on this guy. That's component 3. Let's ground him. We don't want him to move. So now if I try and drag on him, he can't move. Now I can move this other guy, but we've grounded this guy. Okay? And then lastly, let's just do a ball joint. Oops, let me go to Assemble, Joint. For now, let's set it to rigid just for fun. I'm going to say this component here and this component. Actually, you know what? Let's do this the right way. I'm going to do it as an as-built joint because it's already where it needs to be. I'm just going to go ahead and show the as-built joint. I'll say as-built joint. I'm going to set it to ball, and you'll notice as-built joint is very simple. It says, what are the components? And what's the motion type? So I'm going to set it to ball, this component, and this component. And then you'll see on my cursor it says select reference. So I'm going to just click on the ball. And it gives me a preview of what that will look like. So you can kind of see it's rotating in all different directions. I'll say OK. And now if I grab on this part, I can simulate that this is a ball joint. Okay. Now, unfortunately, I can also go into the part, which is not realistic. Okay. So here's a really cool trick. Under the Assemble menu, we have a command called Contact Sets. And I'm going to talk about these a little bit more. But basically, it live checks to see if parts are intersecting with each other or clashing with each other. I'm going to say enable all contact. And it's going to analyze now. As I move this around, it's going to analyze, am I going to hit anything? So you'll notice as I come over here, even though I'm still dragging to the right, it physically can't go any further. Same thing going toward the back here. You can see that it's hitting this shoulder. And I can't go any further that direction. So this is an exact simulation of what this ball joint could do. Okay, pretty cool. Okay, so I'm going to show you as-built joints. Like I mentioned previously, this is probably my favorite part of the Assemble menu. I just find them so useful and so powerful. But what they are is if your assembly is already assembled, for example, maybe you downloaded something off of GrabCAD or Mcmaster-Carr, or you've assembled your, when you designed your assembly, you designed them in place and all that kind of stuff, and now you want to simulate how are those going to move? Well, you would use as-built joints. So I'm going to show you again with a Mcmaster-Carr component. I'm going to say Insert Mcmaster-Carr. I like to make the window just a little bit bigger. And let's do a toggle clamp. So let's just do maybe this clamp here. I'll do these hold down toggle clamps. And I'm just going to randomly pick maybe just like this first one here. It has the little CAD symbol. And let's do a save. And it's going to bring that toggle clamp into Fusion. And this is a huge way of saving a lot of time for something that might already exist. So instead of having to model it yourself, you can just go out and say, hey, is there a toggle clamp? Is there a gear? Is there a pulley? Etc. So you can see it brought this toggle clamp in. Again, I'm going to right click on bodies and say create components from bodies. Now these are all individual components that I can move around. Okay? So they have to be components to be able to move. Okay, so the first thing I want to do is to make something rigid. So for example, I'm going to click on this part here and it highlights that it's component 2. So we'll right click and say ground, and now I physically can't move that part anymore. Okay, I can move the other ones, but I can't move the grounded one. So here's where as-built joints is just so powerful. I'm going to say as-built joint, and a lot of these are Revolute, so I'm going to change this to Revolute. What are my components? Well, let's just say this guy and this guy. And then it's asking for a reference. So what is it going to revolve around? And I can pick on edges. I can pick on cylinders. It doesn't really matter, like faces, for example. Even this blend if I wanted to. Okay? But I'm just going to grab a circular edge. I'm going to click on it, and it instantly gives me a preview of that revolving around. So it was already in the correct location. I just said, hey, revolve around that pin. And now when I grab on this part, we can see that sure enough, it's revolving around that pin. We also see an issue. The rubber handle isn't moving with it. So that is rigid group. Very useful command. I'm going to say rigid group. And I want that guy and that guy to be rigid with each other. So now if I move the metal handle, the plastic one moves. If I grab the plastic handle, the metal one moves. They're rigid with each other. So very, very useful. For example, let's say you're designing a cabinet or something in Fusion, and you have a hinge that has 3 screws on each side. You could have those screws positioned in the holes and say, rigid group, these 3 screws with the leaf of the hinge, and when that hinge moves, those screws move. So let's continue on with this as-built joints. You'll see how fast this is. Revolute, well, I know that this guy and this guy revolve around that edge. I know that, let me kind of zoom up here, this guy and this guy revolve around that edge. And finally, this guy and this guy revolve around that edge. So you can kind of see how I've built all of those joints. Now if I grab my handle, we can physically see how these are going to interact. And remember, I didn't model this. I actually downloaded it off of Mcmaster-Carr, but I'm able to work with it just like it was created inside of Fusion 360. Now, we see an issue. We have this guy over here that's not moving with it, and we can almost think that this is like a sub-assembly. They should all move together. So I'm going to use rigid group, because right now these are all individual components that can move. I want them to move together. So I'm going to say rigid group. That one, that one, that one. That guy, that guy, that guy. So I select all of the parts I want to be rigid. And now if I move any of them, doesn't matter which one, they all move together. Very, very useful. Instead of saying this nut is, connected to this washer, which is connected to this, rod, which is connected, etc., you could assemble it that way. But in this case, we're just saying, hey, those move all together. However, I want it to be able to slide back and forth in the slot. So I'll say as-built joint, slider. I'm going to say this washer and this part right here, and then it's asking for a reference. Well, I just want it to slide along this edge right here, so I'm just going to click on that edge, and you can kind of see it gives me a preview with that washer kind of sliding back and forth. Okay. But watch what happens now. If I grab any of the parts, whether it's the rubber stopper part or the nut or whatever, you can see that sure enough that slides back and forth. And if I grab the handle, they move together. So we can kind of see how that works. And just like before, you'll notice there's a mechanical stop on this flange. If I drag like so, it's actually going to slice through it. In fact, we're going to get some really weird results where it like intersects itself, which obviously can't happen. So let's use that contact set. Now this time, instead of saying enable all contact, I'm going to be more careful. I'm going to specify which parts I want to analyze. If I said enable all contact right now, it would actually try and analyze all of these threads, which it could bring Fusion to its knees potentially. So in this case, I'm going to say enable contact sets, and you can see we get a new little item here in my browser. Okay, and then I'm going to come back in here and say new contact set. So we enabled it. We said turn this option on. Now I want to say new contact set. And it's asking for the bodies or components, and I want to say analyze when this part and this part might touch. So you see two selected. I'll say OK. I'll drag to the right, and notice it stops. Okay, it stops right there because it physically can't go any further. Now I see another issue right here where as I'm moving this around, it's kind of sliding outside of this part here. Okay, so here is where we could set some limits. So I'm going to go into my joints, to my slider, and say edit joint limits. And I can specify my minimum and my maximum limits. So I'm going to say, let's just say the maximum is over to here, or the minimum is over to here, and the maximum is over here, for example. I'll say OK. And now if I grab this guy, you'll see I can't go any further to the right. I can't go any further to the left. So I basically limited how far I can slide that back and forth. Now if I drag this guy here, you can see that it no longer goes outside. So that's the joint limits. Now why would I want to do this? Well, maybe I'm mounting this clamp onto my CNC machine and I want to see, do I have enough clearance for the gantry? Do I have enough clearance for the Z-axis as it's moving along? I now know exactly how tall this particular clamp is. I could take measurements, for example. I kind of know the envelope of this clamp. Okay? Hopefully you found that interesting. I mean, just how quickly I was able to bring in somebody else's CAD data, whether it came from a web page or a customer's web page or Mcmaster-Carr or whatever, and we were able to add those as-built joints into it very quickly and simulate how that thing is going to work. So pretty cool, I think. Okay, the last thing I actually realized, coming back to this, we talked about the between two faces, and I told you I had a better example. So I'm going to go over to this tab right here, and we can see that I have kind of like this rocker arm type looking part and this flange that it's supposed to connect to or something like that. Okay, so I'm going to go ahead and make a joint command here. So both of these are components. So I'll say joint. Which one do I want to move? Well, I want to move this guy here. So I'm going to grab that edge. Where do I want to move it to? I want to move it to this edge over here. And when I do that, it's a cylindrical. Let's just go ahead and say Revolute. Okay. We can see, unfortunately, that there's a huge gap. Okay. And I want this to be centered. Now I could grab this edge, move it over, maybe figure out mathematically how far that should be. Let's just say 2.5 millimeters or something like that. I could do it that way, but that's not how you should do it. Okay, so let's go ahead and do this again. So I'm going to say joint, and I'm going to right mouse click and say between two faces. I'm going to go between this face here and this face over here. Let me kind of zoom up so we can see what's going on here. Now it's asking for a reference. So I'm going to hover over like this circular edge, and again, it's kind of hard to see, but you can see how that plane is now right in the middle between those two faces, and my little joint origin is right in the center axis. So I'm going to go ahead and click there. I'll make this be a Revolute. Now I want it to line up with the exact center here also. So I'm going to hover over the cylinder, control my selection so I can go endpoint, midpoint, endpoint. I'm going to grab the midpoint there. And we can see that it moved my control arm over to the bracket, and we're perfectly centered between those two faces. I'll say okay. Maybe we ground this guy. And now when I grab this rocker arm, we can see how it's going to move on that bracket, for example. Okay. Even though it's kind of, there's no pin in there or anything like that, you can see how that's going to move. Okay, so I'm at the top of the hour. I'm trying to keep these an hour or less. I kind of went through some of the commands in Assemblies. I wanted to show you some of the tips that are not quite so well known, like the between two faces, the which one do you want to move and where do you want to move it to, and stuff like that. So hopefully you found this beneficial. Again, I appreciate all the positive comments I've been getting on these live streams. It makes these a lot more fun. If you have any comments, if you have any ideas that you want to see on future live streams, please put them out into the comments, and I will try and add those to my list and come up with something for you. So with that, I hope you have a wonderful rest of your day. Thank you.